Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, a kind of retrieval that uses no embeddings, no vector index, nothing. And on the right document, it beats vector search outright. It's called PageIndex.
No embeddings at all. Standard RAG is basically defined by embeddings. What's it doing instead?
Let's be fair to standard RAG first. It has one reflex. Embed everything, embed the query, pull back the nearest chunks. It's fast and it scales beautifully. But it's flat. It throws away the document structure and retrieves purely by surface similarity, which means it can grab a plausible-looking neighbor while completely missing the actually right passage.
So what does PageIndex keep that flat search throws away?
The structure. It preprocesses a document into a hierarchical tree. Essentially, it's table of contents. Every node carries a title, a short summary, and the page range where that content lives. No embeddings, no vector index, just the outline.
And then at query time?
At query time, you hand the model that tree, and it navigates exactly like a person flipping to a chapter. At each level, it reasons about which branch is most relevant, descends into it, and repeats until it reaches the right section. Then it reads just that section's pages to answer.
Give me the contrast concretely. Same question. What does each one do?
Say the question is about a company's risk factors in an annual report. Vector search finds the right section, sure, and also drags in a couple of unrelated chunks. Because cosine similarity is blind to where things sit in the document. PageIndex instead walks route, then financials, then risk factors, by reasoning. And here's the kicker. It can explain why it went there. Risk factors live under financials, so I descended into financials.
That explainability is genuinely different. A cosine score can't tell you why it picked a chunk.
Right. And that's the heart of it. Flat retrieval gives you a similarity number. Tree navigation gives you a reasoning trace. On a structured document where the right passage is found by knowing where it should live. That's both more precise and more auditable.
Okay, this sounds almost too good. Where's the catch? It can't be strictly better.
It absolutely is not strictly better. It trades a different set of costs. And this is the honest core of the lesson. A vector lookup is one approximate nearest neighbor query, milliseconds, and it scales to millions of chunks cheaply. PageIndex spends one full LLM call at every hop down the tree. So it's slower and pricier per query by a lot.
So the cost scales with the depth of the tree? Every level down is another model call.
Exactly. And that single fact decides where each one belongs. Reach for a vector database when you've got a huge, messy corpus and you need fast semantic recall across millions of chunks. Reach for PageIndex when you have a small number of well-structured documents, a contract, an annual report, a manual, and the question needs the model to reason about where the answer lies, not just what looks similar.
Bounded and structured for the tree, vast and messy for the vectors. But do I have to choose just one?
No, and this is the insight that makes it click. Decompose. Use vector search first to shortlist the handful of relevant documents out of your millions. Then run PageIndex to navigate within the one you chose. Vectors for breadth, the tree for depth. They're not rivals, they're stages.
One thing nags me. Why is this only showing up now? The idea of an outline isn't new.
Two things had to land at once. Models had to get genuinely good at multi-step reasoning, so they can navigate a tree reliably without wandering off. And context windows had to grow long enough that a node summaries, and then the whole chosen section, fit comfortably in the prompt. Neither was true a few years ago.
So it's really part of a bigger shift in how we think about retrieval?
That's the right frame. The old view treats retrieval as a pure similarity lookup. Nearest vectors, done. The new view uses the model's reasoning at retrieval time. PageIndex is one clean example. Don't just ask what looks similar. Let the model reason about where the answer should be.
So the one line to walk away with?
When a document has real structure, don't flatten it into vectors. Hand the model the outline and let it reason its way to the right chapter. Slower and pricier per query, but precise and explainable, and it pairs perfectly with vector search for the big stuff. That's the Datarekha audio guide. See you in the next one.